Chapter 6.6, we're looking at solving exponential equations. Exponential equations are equations in which variables expressions occur as exponents. So here's a property of equality for exponential equations. If b is a positive real number other than 1, then b to the x equals b to the y, and that's true if and only if x equals y. So for example, if we have 3 to the x equals 3 to the 5th, then if x equals 5, then 3 to the x equals 3 to the 5th. So really, we just set those equal to each other. This property is useful for solving an exponential equations when each side of the equation uses the same base, or can be rewritten using the same base. When it is not convenient to write each side of an exponential equation using the same base, you can try to solve the equation by taking a logarithm of each side. So let's try this example here. We have 100 to the x equals 1 over 10 x minus 3. We want to rewrite each as powers with the same base if they are not already the same base. So we have 100 and we have 1 over 10. They are close. So let's take a look at 100. 100, we could rewrite that as 10 squared. So we want a base of 10. Now we have 1 over 10, so let's make that a positive. Well, 1 over 10, that's the same thing as 10 to the negative 1. So now we have the bases are exactly the same. So we don't want to leave a base with a denominator here, so don't leave it like that. We want to write it with the same value here, okay? So these are the same now. So let's replace that. So 100x, we're going to rewrite that as 10 to the square, and then we still have this x here, so don't forget that that x still needs to belong there. So 10x, right? So the x is still here. And then this is going to equal 10 to the negative 1, right? That's what we said. 10 to the negative 1 is the same as 1 over 10. And then we still have to leave this x minus 3 here. So times x minus 3. So we're using a power of a power property here. So what that means is this is going to multiply to everything inside. So let's distribute that, or we can distribute that later. So we notice that we have the same base. So what that means is we can set the exponents equal to each other. So let's do that. 2x equals negative 1 times x minus 3. Then we need to solve for x. So we distribute the negative. So 2x equals negative x plus 3. Let's go ahead and add x to both sides. We added x. And so, sorry, there's an extra thing there. So now we have 3x equals 3, or x equals 1. So we can try that. Let's try 100 to the first power equals 1 over 10 to the 1 minus 3. So 100 to the first power is 100. 1 to the 10th is to the 1 minus 3, so 1/10 to the negative 2. So remember what that means. It's a negative exponent, so it means it flips it to 10 squared. And so that's going to be 100 equals 100. So that is true. So we did check the answer. X equals 1. Okay, so this is when we need to rewrite with each as powers with the same base. So we're using, if you see a 10, then make it a base of 10. Okay, now let's try letter B. So we have 2 to the x equals 7. Currently, can we rewrite each side as powers with the same base? Looking at it, we have 2 to the x and 7. There's no way that 2 can become 7. So what we're going to do is we're going to take the log of both sides, a logarithm of both sides. We want to use the base of whatever belongs to that exponent here. So the base here is 2. So let me just rewrite this. 2x to the 7 over here. I'm going to make space. 2x and 7. And so what we're going to do is take the log of both sides using the base of the exponent. So this 2, we're going to say log base 2, log base 2. So now that we have that, this cancels out, or that's really 1, right? And that x comes down. So let's rewrite this. This is x equals log base 2 of 7. So in the previous lesson, we learned how to evaluate this using the change of base formula. So we're going to say log of 7 over log of 2. And then when you plug it in your calculator, you get approximately 0.8451 over 0.3010. And then that final answer, x is approximately 2.807. So you need to get some practice. Try solving these exponential equations here. So for all of these, see what you can try to do. Number 3 is kind of a little bit of a challenging problem, but that's okay. So see if you can try these out. Okay, so for the first equation, you cannot get the same base here. So you're going to take the log base 2 of both sides, just like we did in the previous problem. And so the log base 2 of 2, that cancels out. So now it's just x equals log base 2 of 5. Then using the change of base formula, you would get 2.322. For example 2, we also cannot change that. So we're going to take the log base 7 of both sides. So notice I did that here in pink. And then we get 9x equals log base 7 of 15. So 9x equals log base 7 of 15. To solve for x, you divide by 9. So instead of writing it as divided by 9, I just did 1 over 9 here. So you do the change of base formula first. Log of 15 divided by log of 7, then equals, and then at the very end, divide by 9. So just plugging it into your calculator correctly. Now number 3. So what you do here is it's 4e to the negative 0.3x minus 7 equals 13. So you add 7 to both sides here. Then you get 4e to the negative 0.3x equals 20. Let's isolate the e. So divide by 4. So we find that we get e to the negative 0.3x equals 5. Now in order to drop this down so it's not in the exponent position anymore, you're going to take the natural log of both sides. And so natural log of e, that cancels out. And so notice we're left with negative 0.3x equals natural log of 5. Then you divide by negative 0.3 to both sides. And then you do the calculator work. So you press natural log of 5 and then divided by negative 0.3. And you get approximately negative 5.365.